Okay, so we have an equation here, and it says two of the roots of this equation are a plus bi and b plus ai. So obviously this is a complex number question, but it's also a roots of an equation question. So let's just have a think. So a and b are integers. Find the possible values of a. Okay, now the first key step to this question is to note that the roots, if the roots are, so the roots are, if a plus bi is a root, we remember that roots of complex equations always come in conjugate pairs. So if a plus bi is a root, then a minus bi is a root. And b plus ai is a root. B plus ai is a root, which means b minus ai is a root. So they always come in their conjugate pairs. So these are the four roots, and we have four roots for a polynomial equation of degree 4. So what can we do with that? Well, we can say that the sum of the roots is minus this over this. This is from our sum of roots formula, also in the formula booklet. So sum of roots is minus 4 over 1. And the product of roots is this over 1, which is 400 over 1, which is just 400. So this is minus 4, and this is 400. Now we have the roots, so let's just make some equations. So the sum of the roots is a plus bi plus a minus bi plus b plus ai plus b minus ai. And this is equal to negative 4. Now obviously the bi and the minus bi cancel, the ai and the minus ai cancel, and we're just left with 2a plus 2b equals negative 4. And we can actually simplify that into a plus b equals negative 2. Okay, that's the sum of the roots. The product of the roots is then this times this times this times this. So the product of the roots is a plus bi times a minus bi times b plus ai times b minus ai, and this is equal to 400. Now, I know I can multiply these two out, and it gives me a squared. I get my minus abi plus abi, so they cancel, and I'm just left with a squared plus b squared, because my b times b gives my b squared. There's a minus, but the I times I gives me minus 1, and I'm left with plus. That's a nice one to remember, guys. A plus bi times a minus bi is a squared plus b squared. And then this is similar here. This is going to be b, and this is going to be b squared plus a squared. This equals 400. Now this is actually, this times this is, that's the same as all of this squared. This is like a squared plus b squared squared, because obviously look, this is the same thing, isn't it? So a squared plus b squared is equal to the square root of 400, which is going to equal, sorry, what am I doing? 20. Okay, now what are we doing? Okay, we have this equation here. So I have a plus b equals minus 2, and I have a squared plus b squared equals 20. Now he said find the possible values of a. So I'm going to sub this is equal to, if you like, this is equal to a equals minus 2 minus b. So I wanted to do b. Sorry. B equals minus 2 minus a. So I'm going to sub that in here. So I can say a squared plus minus 2 minus a squared equals 20. Now I just have a quadratic that I can solve. A squared plus, this is going to be 4 minus 2 times minus a, which is, or sorry, minus 4. This will be minus 4, or plus, sorry, because minus times minus is plus. This is going to be plus 4a plus a squared equals 20. Add these two here. I have 2a squared plus 4a plus 4 minus 20 is minus 16 equals 0. Divide by 2. I'm doing this bit quickly, guys, because it's just a quadratic. You can figure it out. Minus 8 equals 0. Factors of 8, 4 and 2. A and a, 4 and 2. This must be plus, this must be minus. A plus 4 equals 0, or a minus 2 equals 0. And then I'll just do it over here. Therefore, a equals negative 4, or a equals 2. And that's the two possible values of a.